the sum of the terms in the sequence. Okay, so if we have a finite sum, or excuse me, a finite sequence, 1, 2, 3, 4, we're just adding up those numbers. 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is 10. So the series of that sequence is 10. I'm sorry. Yes. Okay. The series of that sequence is 10. All right. The next one, 3, 6, 9, 12, that's an infinite sequence. So we're going to keep adding numbers to the sequence. So if we keep adding numbers to our sum, it's just going to keep getting bigger and bigger and bigger. So the series here is infinity. Now, probably on the final exam, if they ask you something about that would not technically have a sum, okay? They wouldn't have infinity as the answer choice. They would say that the sum cannot be found because you're continuing to add numbers, so that sum continues to increase. So technically, it doesn't have a sum. Okay, same thing. Well, no, hang on. Let's look at this last one. 1/2 plus 1/4 plus 1/8 plus 1/16. Yes, this is an infinite sequence. The numbers are continuing to add to the sequence, but what's happening to the numbers? They're getting smaller and smaller and smaller and smaller. So let's add up these first few and see what happens. We've got 1/2 plus 1/4 plus 1/8 plus 1/16. Okay, so what do we have so far? We got 0.9375. What would the next number be? 1/32. 1/64. Brandon's got the sequence stuff. Okay. Whoops, I got my plus. Okay, so what does it look like is happening? It's getting bigger, but I mean, yes, but we're adding every time it's getting smaller, so our sum is getting bigger, but it's not really getting bigger anymore. It's heading off. It's going to end up kind of leveling off. Hey. Okay. The sum of this sequence, even though it's infinite, it does have a sum because those numbers that we're adding every single time are getting smaller and smaller and smaller and smaller. So eventually they're not making a difference. Okay. Eventually they're not making a difference. Okay, so what we are going to look at is what we do call partial sums. So we use a capital S with a subscript of n. That's the sum of the first n terms. Okay, S sub n tells you to find the sum of the first n terms. So S sub 6 would be the sum of the first 6 terms. S sub 15 would be the sum of the first 15 terms, okay? So in number 1 there, we have the first 5 terms. They want us to find the sum of the first 9. So we got to find the next 4. Well, what are we doing? We're just counting by ones. So we're adding up 1, 2, 3, 4, 5, 6, 7, 8, 9. What'd you get, Taylor? 45. A whole lot faster than me typing into that. Okay? So number 2, 4, 7, 13, 25, 49, find S sub 4. So just the sum of the first 4 is 49. Kind of interesting that is the 5th term, but just a little coincidental there. Okay. All right. 1, 4, 9, 16, 25, find S sub 6. We have the first 5, so what would be the next term? What are we doing here? We're adding 3, we're adding 5, we're adding 7, we're adding 9, so 11. Oh, would that be exponential? Yeah. Yeah. Yes. It'd be quadratic. Yeah. It'd be n squared. Okay, so if we add those up, we get 91. Okay, and then the last one, S sub 3, so just adding up 1, 1/2, and 1/3. Y'all know I like fractions, so that is 11 over 6. Okay, so easy peasy. Let's talk about summation notation because this freaks people out. It's not that complicated, but they look at it and they're like, oh, they just spaz, okay? So we use the Greek letter. Anybody know what the Greek letter is? It means summation. It's sigma. It's not theta. You don't know what theta is. Sigma. Okay, this is the Greek letter sigma, so it starts with an S. That's why they picked it for sum. Okay. It looks like a what? It looks like an E. I know. The Greek letters, they don't make sense. The G looks like an F with the second line left off. I mean, they're English, they just screwed up the alphabet. But anyway.
So we screwed up the alphabet?
Well, which one came first?
Doesn't matter. We're wrong.
Okay, that's a big for another class, but the Greeks came first, if we didn't know that. The Greeks came first, so their alphabet existed first. Okay, anyways, back to the math here. All right, so it denotes that you're finding the sum. So what we've got here, the bottom here tells you the first term. Okay, the first term. Now, here's the reason why we need this. Is because we don't always want to find the sum of the first 6 terms. We may want to find the sum of the 3rd through 9th terms. So we need the sigma notation to be able to tell us that. The regular summation notation can't tell us that. The number on the top, what do you think that is? The last term that we want to include in our sum. So this one's representing the sum of the 1st through the 5th terms. And 2n is your explicit formula. Okay. Let me write that this is sigma. S-I-G-M-A, sigma. Okay, so let's find the sum of this series. So we start with 1. We've got 2 times 1 plus 2 times 2 plus 2 times 3 plus 2 times 4 plus 2 times 5. So 2 plus 4 is 6 plus 6 is 12 plus 8 is 20 plus 10 is 30. When we get to arithmetic and geometric, yes. Arithmetic and geometric sequences. It's a good question. We'll get to it when we talk about it. We'll have a little English lesson in math class, but we won't be able to get to that till tomorrow. It's spelled the same way. It is spelled the same way. Okay, so let's find the sum of these series here. From 1 to 12 of n minus 1. So we start with 1, and then 2, and then 3, and then 4. Technically, I guess these should be in parentheses. Plus 5, plus 6 minus 1, plus 7 minus 1, plus 8 minus 1. Whew, okay. Now, there is, let me see if I can, it's been a long time since I've done it in the calculator here, but there is a way. When you do that all, you get 66. So, let's see.
You got 1 plus 2 plus 3 plus 4 plus 5 6 plus 7.
Okay. Yes, but I was expanding it. I know that I know. All right. So you can put this. You can put 1 through 12. Let me look and see. Yeah. 9, 10, 11, 12. Okay. Let me show you how to do this. Okay. Stat edit. Put 1 through 12 in list 1. Then you're going to move your arrow up to where the L2 is. We can put a formula there. So it's L1, you're taking what's in list 1 and you're subtracting 1 from it. And looky there, it produces all the numbers. Okay? Now, how do we find the sum?
Multiply by 6.
No. You go to, it's somewhere. Where is it? Number? No. No. Oh man. There are statistics?
Oh, is that a signal right there?
Yes.
Hey.
But there's a sum somewhere. Hang on. Where is it? Yeah, we maybe should be able to do this. No, it's sigma x. Nope, that doesn't work. Okay. Let's just go to the catalog. There's a sum. I just can't remember where it is right now. Yes, it has every single function in your calculator. There it is.
Here you go, baby.
Oh, you know what? It's under. Well, I'll figure it out here in a minute. Sum of L2. Second zero. Yes, it literally has everything that's in your calculator. Okay, I'll figure out where the sum actually is, but it's under the catalog, nowhere else. Okay? So then if we wanted to do the next one like that, what we would have to do is under stat edit, we would need to remove 8, 9, 10, 11, 12, okay? Because it'll add up whatever's in list 2, okay? If it's in there, it'll add them up. So go back to list 2 up here and hit -3 list 1. And then you can just press enter again, and it'll figure it out for you. Okay. Now the next one's not that hard, so let's just do this one by hand. 1 through 4. Okay, 1 through 4 is not that hard. 5 times 1 is 5, plus 2 is 7. 5 times 2 is 10, plus 2 is 12. 5 times 3 is 15, plus 2 is 17. I don't know why I put a comma there. That should be a plus. And 5 times 4 is 20, plus 2 is 22. So if we add those up, we get 19 plus 7 is 36, plus 20, 58. I am all confused. There we go. Equals 58. Okay, notice number 8 kind of flips it on us. It wants 2 through 9. Okay, it wants 2 through 9. So if you wanted to use your calculator, since there's a few more of these, make sure that your list 1 starts with number 2. Okay, 2 through 9, 8, 9. And notice they use an A instead of an N. It's fine. All right, it's the same difference. It really does not matter. Don't know why I put parentheses there. Okay, it gives you terms, sum, 32. Okay, if we were going to do number 9. Okay, number 9, if we're putting this one in, we need 1 through, if you press second inserts, it'll let you put the 1 back in there. 1 through 5. Always make sure you use the delete key and not the clear key. Or no, actually you want to use clear right there. My bad. Okay, y squared plus y. So it's list 1 squared plus list 1. Okay. So those are our terms. Add them together. 7. You're going to be able to do it in your head? I mean, you should be able to do it in your head. I'm just using the calculator to make it quicker. I mean, don't forget, okay, let's do it on this one. To do it by hand, you just start with that number on the bottom and start counting up. Well, like I said, when we get to the arithmetic and geometric ones, there is a formula, okay? But if these aren't These aren't arithmetic and geometric. They're something else. So we gotta do a little bit more work. Okay, when you add this one up, I'm just gonna tell you it's 647.5. Okay, number 11, we start at 2, we stop at 6. That gives us 85. Okay, I'm rushing because I want to get to 12 and 13 really quick. Okay, 12 and 13 are a little bit different. Look, they have something in front of the sigma. That's okay. You just find the sum like you normally do, and after you find the sum, multiply by 3. Okay, so it's just going to be 3 times that sum, which is 30. 30 is the sum, and that ends up giving 90. If you were typing that one, if you wanted to do that one in your stat edit, obviously pay attention. It's 4 through 8. So you would do 4 minus this one. You got to put those parentheses and square it. Okay, and then the same thing with this last one. It's 1/2 times the sum, which ends up being 14, and that gives you 7. We're only going from the second to the fourth term. That's why that one's so small. Okay? All right, so hang on to these packets, please.